In this clip, we'll be talking about circulation of water in the atmosphere, and we'll be talking about the many phases of water and some atmospheric terms that's related to understand the circulation and the phase of water. So within the atmosphere, there is an unending circulation of the water. Since the ocean occupy over 70% of the Earth's surface, we can think of this circulation as beginning over the ocean. Here, the sun energy transform enormous quantity of liquid water into water vapor, and this process is called evaporation. Then, wind transport the moist air to the other region, where the water vapor changes back into the liquid, forming clouds. In a process, we call this condensation, and the saturation condition and condensation. Under certain conditions, the liquid cloud particles or solid ice crystal may grow in size and fall into surface. It's called precipitation, like in the form of rain, snow, hail. So any object is falling from the sky to the ground is precipitation. If the precipitation fall into the ocean, the water begins its cycle again. If one, on the other hand, if we say that the precipitation fall on a continent or a land, a great deal of water return to the ocean only after a complex journey. And this cycle of moving and transforming water molecule from liquid to vapor and back to liquid again is called hydrological cycle or water cycle. In the form with which we are most concerned, water molecule travels from ocean to atmosphere to land and then back to ocean again. This is hydrological cycle. Okay, so over the land, a significant amount of water vapor is added to the atmosphere through evaporation from the soil, from the lake, and also from the stream and so on. Even plants gives us moisture by a process called transpiration. The water absorbed by a plant root system moves upward through a stem and emerge from the plant through numerous small openings of the underside of the leaf, and many things happens here. Well, in all evaporation and the transpiration from the continent area, what is the amount? The total amount would be something 100%, and excuse me, among 100%, only 15% of the total evaporation is coming from the ground or from the continent, and this amount is 1.5 quadrillion. And what does this mean? This means 10 to the power 18 gallon of water vapor that annually evaporate into the atmosphere. The remaining 85% of the water vapor is coming from the ocean. If all the water vapor were to suddenly condense and fall as a rain on the ground, it would cover entire globe with thickness of 1 inch. Okay, so we know from here that water cycle, we have understanding of evaporation, condensation, precipitation, hydrological cycle, transpiration. So those are the important terms that you need to know for the exam and quiz. Now I'm actually moving forward to the many phases of water. If we could see individual water molecule, we would find that the lower atmosphere water is everywhere. If we could observe just one single water molecule by magnifying this billions of times, we would see an H2O molecule in a shape of a tiny head, somewhat resembled to Mickey Mouse. The bulk of the head of the molecule is the oxygen atom, and oxygen atom is charged positive, and we have hydrogen atom. Oxygen atom is negative and hydrogen atom is positive. So that's this making attraction and making H2O. Well, when we look at many H2O molecule, we see that a gas, water vapor molecule move about to quick freely and mixing well with neighboring atom and molecule, as you see in the picture. As we learned previously, the higher the temperature of the gas, the faster molecule moves. In the liquid state, we call water, the water molecules are closely together, constantly jolting and bumping into one another. If we lower the temperature of the liquid, water molecule will move slower and slower until, when cold enough, they arrange themselves into an orderly pattern with each molecule more or less locked into a rigid position. And they are definitely able to vibrate but not able to move about freely like gas. In this solid state, we call ice. The shape and the charge of this water molecule helps arrange the molecule into forming a six-sided crystal. We also call it hexagonal ice. As we observe the ice crystal in the freezing air, we see an occasional molecule gain enough energy to break away from its neighbor and enter into the air above. The molecule changes from an ice molecule directly into a vapor molecule without passing through the liquid state. This ice to vapor phase directly is called sublimation. Sublimation. It is important. If a water vapor molecule should attach itself to the ice crystal, the vapor to ice phase change is called deposition. So we know sublimation and we know deposition. So what does those things means? In the sublimation, directly solid to gas, in between no liquid form. In deposition, direct gas to solid, in between no liquid form. So by now from here we have to know all these terms: condensation, deposition, sublimation, melting, freezing, vaporization. So you must have this understanding. Okay. Water vapor is a gas that becomes visible to us only when millions of molecules join together to form a tiny cloud droplet or ice crystal. This process known as change of state or phase change. Okay, so when this change is happening, it's only happening the changing the state of water, not chemically changing its property. So that's we all need to know. So from this video clips, we know evaporation, condensation, precipitation, hydrological cycle. We know sublimation, we know deposition, and we also know the three phases of water. Thank you.